again, my friends. Welcome once more back to the cellar. Welcome to Leopard Street. In this one, we're going to have a little look at what I've been up to. I've commissioned a new board into the layout, added the block detection, brought it into JMRI. We'll have a little look at that. I found a problem with one of the components on the layout. Slightly infuriating. Diagnosed a fault back to the source, and I've fixed it. Have a look at that as well. And then, finally, as you can see, I have trains running. I've added a little bit more signal logic to the layout. There are no signals on the layout that work apart from the two behind me. We're going to have a little look at that as well. So, stick around. This is Leopard Street. Okay, so first off, the G5 sets off. I've commissioned this board. This is board J. You might not notice anything different. Yeah, it was working before. Whee, Spike having a run. It's now fully operational. So to start with, we have a proper power connector. This is hooked into board D. Goes down onto the power distribution pieces, comes back up. This was just 2 bits of flying lead for the DCC bus. Secondly, as you can probably see from the glow under here, I've fitted some bits. So under here we have a board controller, which is one of my ESP32 board controllers. We have a TLC 5947 LED controller, which is eventually going to be controlling some color light signals and then eventually some buildings. There is a PCA 9685, I believe it is. Yep, so servo controller. And somewhere there is a PCF 8575. Oh, there's a PCF 8575. Yeah, we're going to come back to that one. And then there is a pair somewhere of DTC2s lurking at the back, which handle block detection. So if we come back onto the top, what we have, find a little piece of plastic. Can't use metal because the layout is operational. So this inner track is the inbound track. It has a yellow dot. The yellow dot will be a signal. This is going to be the outer home for the station approach. So what we have is a signal and a block. Now, as a train comes around here, got a freight train running. As the train comes around here, it'll be going, oh, approaching something, 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 crosses this joint onto this block here. If this signal's at red, this is where it'll be told to stop. And then it has another section, which is just the next part of the next, another block, which is the next part of the next section. The outer track, which is the departure track, trains rumble around here. They hit this bit here. And this is just more track, this bit. Hit another insulating section. There'll be another signal over there. Now that is the advanced starter for the station. So that is also going to mark the limit of shunt. In practice that might be a little bit further back. But there's another insulating joiner. So what I've got is a block here, a block here, a block there, and a block there. So I've got 4 blocks. Hence why I've used 2 of the DTC2 connectors, and that's it. Now, on its own, this doesn't really add a great deal of operations to the layout. Trains still run. However, the block detection means I can see where things are. So what we're going to do, I'm going to leave these trains running. We'll come back to them in a minute. What I'm going to do is I'm going to run a few trains over this section. I've integrated it into JMRI, and we'll have a look. So, to the desk. Okay, so as you can see from the layout picture, that is the board setup. On screen over here we have where the 2 signals are. I'm just going to manually change them both to green. They're shown as crosses because they weren't connected to anything. So we now have these bits here. So I'm going to start off with the innermost line. This is the station approach. This is my J26. I shall turn some sound on because I can. You can hear over the sound of the other bits and pieces rolling forward. Now, she's showing as red up here, which is where she's been before. I've now added this little bit here, which is board J. So here we are up to the signal. And she's going to carry on rumbling through at a relatively sedate speed, as befits a locomotive such as herself. We'll speed up a little bit. And she rumbles in. And as you can see, I can monitor the progress. Now, monitoring the progress is useful because if I can monitor the progress, I can do things with it. So I can now see a train all the way up the incline. So if we come around from Leopard Junction, which is over here, all the way around on the inner line, up to the outer home, which is nice. Meanwhile, on the outermost line, we have Bucky the Ever Faithful, who is somewhat loud. What do you reckon, Bucky? Yeah. So off we go. She's going to have a little wander down on the outer line, nice and slowly. And again, I mean, I've been driving trains on these tracks for a couple of weeks now, in fact, probably a couple of months. But what I've not been able to do with these particular pieces of track is monitor where they are with my control system. So a little bit of work over the weekend, and we'll come on to some of the more interesting problems that go with that in a mo. Tell Bucky to come backwards. So she's now over here. This is board A. One of the things I'm starting to do is document the layout a little bit better. I'm going to come on to that in another video, because if you're going to do anything like this, you really do need to start writing stuff down. Otherwise, you can get a little bit tangled up. I was setting up the trains to run automatically earlier, and I was having all sorts of fun and games. We shall be watching those in a mo. So here we are. She's coming up. Now, obviously, she's running wrong way at the moment, but never mind. Yeah, so I'm going to have a limit of shunt there, which is basically Bucky normally won't go any further than this green signal up here. So we shall bring her back up. She's back into part of the layout. And I'll tell her to stop. Yeah, so that has brought board J, and all that's really done is bring in these two little bits of track here, but it helps out. The signalling logic is going to carry on, and we'll look at that in a mo. But that's board J. Okay, so this is Leopard Street. It wouldn't be Leopard Street if something hadn't gone wrong. So what actually happened? This. Yeah, bring this a little bit closer, you'll be able to see this. This is a PCF 8575. It had OK written on it because I'd tested it and I thought it worked. It's now got a cross on it because I found a problem. Now, I did a video recently, so I've got a pen, on the 8574. Well, this thing is more or less the same. What you've got is plus VCCs, you've got power, you've got ground. You have SDA, which is a data line, which works both ways. You have SCL, which is a clock, and then there is an interrupt going out. If you want to see how that works, look in the previous video. It's in the Frazzled series, I believe. And off the side of this thing, you've got, I'll get this the right way around. You've got ground, you've got voltage, same on this side, ground, voltage. And down here, you've got 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Input lines, these are 0 to 7, and up here is 8 to 15. That one's 8, that one's 7, 0, and 15. Probably hear the train still running behind me. Yeah, testing the layout out. Now, the way I use these things, that's the chip. It sits on its little board. And I have set up in code, these are, get me this the right way around, these are inputs, and these are outputs. And I connect the output. The way these work is you want to put current into them. So when you set it to be an output, if you want it to be the output to be on, you write a 1 to it, because that means the pin goes to the high voltage. If you want it to drive something, you set it to 0. So what you have up here, say, is a thing. And you connect that to your plus voltage, and it goes into there. And you can turn things on and off. Now, what I do with that, I test that. I use a relay board. If I can just grab one. Yeah, one readily to hand. One of these. And the reason I test them with relays is that's what they're driving. And these are the relays I use for frogs on points, which is basically what this thing drives. And it can drive up to 8 of them. Brilliant. So what you do is you write out to the thing 0x because it's in hexadecimal. And then we go F, ignore the E. And we'll come back to the lower digits in a minute. And these control these upper bits. So if you put FF, they're all on, nothing happens. If I were to write out F, I'm trying to work out which it is E. That would drop that bit to 0 and turn the thing on. In this case, a relay. So you need things which are active low. So basically when the current passes, away it goes, which they are. Now when I test these boards, I plug 2 relays in. Basically I plug a connector in that's got 2 relays, and I write to them. And the relay went click, and the relay went click back. Happy, it works. Yeah. Didn't test the inputs. Now when I connected this to the board, my software looks at what we get here. Now briefly, the way this works is you write a value to it. If you want it to be an input, you write a logic high. So you write a 1. And then you immediately read it back to see what it is. Now, if it's not connected to anything, it'll be a 1. And what we do is it's connected basically like this down to ground. This is within my DTC2. It's called an open collector. And what it is it's either connected to nothing or it's connected to ground. So you come up with internal pull-ups. Anyway, that's what this thing does. So normally, that's at logic high. Oh, I've detected something. It goes to a 0, and you'll read the 0. You think, brilliant. So I write out, to start with, all Fs. F is basically that in binary. It translates as 15. Basically 1, 2, 4, and 8. All lit up, you add them together, you get to 15. If you want a video on binary, to be honest, there's better people to explain that than me. So, yes. Now, I connected this. Now, my software sees a 1. So, a 1 is inactive because the sensor hasn't triggered. And it sees a 0 as active. So what I've got is I've got those 4. No, I think it's these 4 here. I think it's the lower 4. And they go to blocks. Very nicely. Now remember how this works. If there's nothing connected to it, every line should be saying inactive. And it wasn't. They were all saying active. Thought, bit odd. When I set the layout up, I wasn't getting the sensors that were coming in. I was getting them all saying active. Doesn't sound right. Thought, I'll run a train over it, see what happens. And perhaps unsurprisingly, nothing. So I took the board back out. I started checking my wiring. The DTC2s have a little red LED on them, so I ran a train over it and watched the LED. Yeah, they're working. Well, have I done something in my code that's wrong? So I came up with a little script, and all it does is it took one of these things and it says what value has it got. Read all 16 bits back in. So write them all out as high, read them back in. And what it should come back with is FFFF or FFS, if you, as it turned out. And it was coming back with a 0. That's odd. Yeah, then none of them are reading. For whatever reason, this chip doesn't work correctly on the inputs. What I found was if I put a high voltage on one of them, it read it. So somewhere, the bit in the chip that's reading the voltage is correct. But the bit that writes to these pins properly isn't working right. Don't know why. So I thought, how do I validate that? Well, what I did is I got another one. Unfortunately, I had a few more of these things. So they come in packets like that. I thought, well, I'll give it a try. So I built another one. I put that on my test rig, and that worked perfectly. I thought, okay. Glued it to one of these little boards. I installed that on board J, switched everything back on, and they all came up inactive. And I thought, ooh, that's different. Powered the track up, ran a train over it. Lo and behold, it works perfectly. Took about 2 hours to diagnose that. One of the problems I've got is it seems to be a bad batch. Don't know why. I installed that on board J and it doesn't work. I've got one on board K, which hasn't got block detectors, so it's not connected to anything yet. That is reporting all active, so that one isn't working either. Board M has one of these. I'll give you 3 guesses. Yep, that one doesn't work either. And board L has got one of these as well. L has got one, M has got one, and N has got one. And none of them work. So I suspect it's a bad batch. I've ordered some more. They're coming. I'm going to test them properly. One of the things I'm going to do when they turn up is I'm going to make an actual test rig, and we're going to have a look at that. But yeah, so that was my Saturday. This is one of the reasons there wasn't a video on Tuesday, as I spent most of Saturday pulling what's left of my hair out, diagnosing these things, so I didn't really have much of a chance. But yeah, so found a fault. It's annoying, but I know what the problem is, and I fixed it for board J. I know how to test these things for the other sections. So yeah, that's that. So that'll be coming up, and we'll get those working. Anyway, back to trains. Okay, enough of that nonsense. Right, what else have we been doing? Well, board J is integrated. As you see, the signals there are manual. Now, as you can see on the screen when trains are in shot, I've got trains running. I've been playing with my automation system again. I'm not going to go overly much into that as Spike wanders past. Spike is this red line here. I've not told it which trains are which is why it's not following them round. And here comes the G5. There we go, so she's going to run round. Now what I've done, I've had a play with the signal logic thing that JMRI does, so signal mask logic. So if we follow this little train around here, this is my, who is this one? This is the Q6. He's rumbling around here. So she's coming out, she had a green light to go, she's got a red light behind her. Sorry, red light ahead. But she's going to rumble round here, and she'll get to a point, and that signal will change. She'll go around, as we see, here she comes. And the reason it's red is because the point is set for another route. So that point is now changed, green signal. So Q6 will carry on, and she will rumble round here, back into her siding. And as she comes in, Spike is going to set off again. Spike has currently got a red signal. because the route isn't set and the track isn't clear. The track is now reporting clear. It actually isn't. The tail end of the train is still in that section, but there we go. That goes to green, and off goes Spike. So the trains are not driving to the signals yet. In truth, the trains, my automation doesn't even know these signals exist. There's a lot more work I need to do with that. But I've added them in, basically just to see if I can get the signal logic working, as Spike thunders round again. And she's coming round here now, round onto this route. Now she's going to keep going. The signal is still green. She slows down a little bit as she enters. And she's going to keep going. There's nothing to say the route is going to change. She speeds up again. And she comes. Meanwhile, the G5 is coming in. That's going to stop. I have my K3 rumbling round up here, which has just reset the route down here. Now she's going to come in. And when she gets to about here, this one's going to change. So again, these signals are going to change. And this is GMI, as I say, signal mask logic. I'm going to do another video on this because I've been doing a little bit of experimentation. I've actually got some cheap colour light signals on order, which I'm going to add to the layout in lieu of the. So the Q6 is going again, and the Spike has stopped. Yeah, so I'm going to fit some of those on. I will be putting semaphore signals on here eventually, but it's not happened yet. So what we're also going to do, I'm going to bring the camera down, we're going to have a look into Underworld, so to speak. So here we are, here is the lower part of the layout. So we have Spike sitting in front. Q6 will run round. See in the distance the other two quite happily. The points round here are set for the G5 to come straight in. Spike will set off momentarily. Just waiting for the Q6 rumbling around in the background. Yeah, so you're thinking, what on earth is the point of this? Especially the signals I've put. Got that there. The signals over here on the reversing loops. Well, what's the point? Well, essentially, what it's doing is it's giving me, as the Muppet who's trying to drive this, Spike setting off, some warning. So, if I've got a train, hold my mouse. If I've got a train in one of these two tracks here and I'm wanting it to go, I can look at that and think, I want my Q6 to go, but the signal's on red. Yeah, signal on red means there's something wrong. Oh, there's a point that's not set. Or this crossing is not set correctly. In fact, what I'm going to do, I'm going to tell my automated system to give it a rest. More trains are going to run round. They should now all complete the lap they're on and then stop. The key bit there is I can then start playing with the points, and I'll show you how some of it else works. Spike thunders round in the background again. And incidentally, I've had these 4 trains running round now for the best part of half an hour, without any real problems. I had one derailment early on where a wagon decided to be naughty, but yeah, that's what it is. So the trains are going to come around here. Spike is going to stop, not triggering the other train. G5 is going to wander around, and I'm going to quit my automation software. So, what we've got here is points. Now, this signal up here, this is one of the interesting ones. This is configured, and at the moment it's showing red. And it's showing red because there's nowhere for a train to go. It's set for this road, which is blocked. So basically the signals are stopping points. So a train cannot get from that signal to that signal, which is what the track is set for, because there's a train in the way. If I change those, it stays red, because there's now a different train in the way. But if I do this, get that one to work, we've now got a path through here into a loop. There's a green signal. No, why hasn't it changed? This one here also needs to change. At the moment, we've got a collision risk. So if I change that to register, changes, this signal now goes green. we now have a valid path from there down to this signal. If I change that one, it'll stay green because we have a valid path around there. It should. It goes red briefly, basically as the point moves. Same with this one here. You can say onto the inner loop. It runs. I'm going to keep it on the outer loop because the outer loop's the easiest one to use. Also out here we have an output signal, so this is for my storage lines here in the loops. Oh, it's got a route out. Oh, this one's got a route out. Oh, this one's got a route out. Now, this really is, basically it's Muppet territory for me. These ones are showing green. They will go red if a train goes into this section. The automation will eventually be able to pick this stuff up and work with it. It can't at the minute. But this is telling me here, if I were to bring Spike out, there's something wrong. That's this crossover here. So I'll set that. Spike still can't go because this one is routing a train across. So the route has to be safe. Now, in layout terms, that's quite useful. The risk of a collision is there. It's quite a real risk. But equally, if that point is set that way, I know electrically this crossing is set for the crossing route, not the through route. So if Spike comes along, zzz, there'll be a short circuit. So it tells me there's something wrong. As I play around with the Mimic board a little bit more, I'm going to start putting block occupancy in, which is going to be red. So it's going to be, this train wants to go somewhere, you follow the route round. Ooh. Just wait that point to change. Oh, there's a red light. Well, I've got to stop, I can't go anywhere. So the signals are where I can stop trains. Like I say, eventually there'll be some more up here, and I'll deal with that as the time comes. But that's what I've been playing with the signal logic, and as trains rumble round, the signals change. It's quite a nice little idea. So, yeah, that's what I've been up to with signal mass logic. So then, that's been this week at Leopard Street. One of the comments I had, yeah, I don't necessarily put videos out. I try to put videos out a couple of times a week. 3 times a week depends on what I've been doing, really. Over the weekend, had a few problems, so yeah, I thought what I was doing wasn't particularly visually interesting, so I didn't bother with it. I have, however, been watching trains run. I like watching trains run. So in this one, we have commissioned that board. In and of itself, it's not much, but it's starting to bring the information management round to the station. The next board will be that one, which gives me the station approach and the first of the points and the loco yard. I haven't quite decided how I'm going to do that yet. We've also had a little look at the problem I found with the PCF 8575, which was annoying, but is what it is at the end of the day. That's now fixed. I've got replacement parts on order, which will go onto the rest of the station boards. I'm going to do them as I'm working on the boards. I didn't get around to putting the relay boards in because I was fixing that, so it is what it is. And we've also had a little bit of a play with the signal mask logic. That was yeah, it's all working. Sounds a little bit weird. Um, I just wanted to see how it worked. I'm going to do a proper video on signal mask logic. Uh, I did start trying to do one over the weekend. It was more gibberish than usual, so I scrapped it. So I'm going to carry on with that, and we'll have a look at some bits. There's some things I've tried to do with it that didn't quite work. There's some bits it works in a bit of a convoluted way. We shall come back to that. Anyway, apart from that, I'm just watching trains running. This has been Leopard Street. As usual, likes, comments, shares, subscriptions, yada yada yada, all the usual YouTube stuff. More than welcome. I'll catch you all on the next one. Till then, I'll leave you with some trains running. Thank you very much for watching, and goodbye.